Alright, in this video here, I'm going to be working off of document number 10. And I'm going to try to do two things at once with this. By now, you should have already filled in all of the orbital notations for these elements listed on this document. And you should be working towards translating those orbital diagrams into electron configuration. I know that some people are still struggling with the idea of filling in these orbital diagrams, so I'm first going to do a quick review of that as I fill out a couple of these, and then I'm also going to translate them into electron configuration. So let's get started. We're going to start off with technetium first. Technetium is in the middle of the periodic table. Right here it is element number 43, so we know that that means it's going to have 43 electrons. Again, just as a review, we have to use Aufbau's principle to know where to start and where to go once we have filled those orbitals. Which orbital comes next? We do want to make sure that we're using our opposite spins with our arrows, and also that we are applying Hund's rule when we reach those p orbitals, d orbitals, and f orbitals. So, over here, technetium, 43 electrons. According to Aufbau, we have to start here at the 1s orbital, which we fill. Then move on to the 2s orbital, and after the 2s orbital, according to our arrows, after 2s comes 2p. I've heard a lot of discussion of students over the little time that I've been in class just saying that you just fill it up left to right and then move up. Remember that once you reach a certain point, that's no longer true. And when that point happens is when we fill the 3p orbital. A lot of students are tempted just to move on to the 3d, but this would be incorrect according to Aufbau. When we look at our arrows here, we go 1s, 2s, then back to 2p, then 3s, then 3p. After 3p comes 4s, not 3d. So don't get into this habit of just filling left to right and then working your way up. You have to make sure that you're following the Aufbau diagram to be sure that you write these correctly. So after 3p comes 4s, which I place 2 more in. At this point, I'm at 20 electrons. Now I move into this 3d, where you see how I'm following Hund's rule by placing one arrow up on each line and then coming back to pair them. And when I pair them, I'm following Pauli's rule, or I'm making sure I pair them with opposite spins. If I go back to my Aufbau diagram, it tells me after the 3d, I go on to 4p, and then on to 5s. So at this point right here, I have 30 electrons in my picture. This is going to be 31, 32, 33, 34, 35, 36. After the 4p comes the 5s. Again, you might be tempted to move into this 4d level, but that would be incorrect. We have to come up here and hit the 5s. At this point, we now have 38 electrons. We're looking for 43, so we only need a couple more to go. After the 5s, according to Aufbau, we come back and we hit that 4d level. So we're at 38. This is going to be 39. This is going to be 40, 41, 42, and 43. Here we stop because technetium only has 43 electrons. And once I've placed 43 electrons, I stop. Again, see how I've followed Hund's rule by placing one electron on each line. I ran out of electrons before it was necessary to start pairing them. Again, this is okay. This is just technetium's orbital diagram. Moving on from this, we're now working on translating these orbital diagrams into electron configuration. So up here I have our notes page, which you got on Thursday. This is document number 12. And you were to watch a video over me explaining the two methods, reminding you about orbital notation, which we just went over an example with technetium, and then looking at how are we going to translate that into this easier notation of electron configuration. Remember that we still use our quantum numbers, where this number out front, much like a coefficient, is your energy level. This is your principal quantum number. We still use the SPDF to represent those orbital shapes. But instead of having to draw all the lines and arrows, we're now going to condense all that information into a simple subscript or superscript to notify how many electrons are in that particular orbital. So let's look at our example here, technetium. We've used the 1s, we've used the 2s, and the 2p, and the 3s. So we're going to list all of these orbitals out that we have electrons in. But this order that we place these this information is very important. We still have to make sure that we are following Aufbau's principle. So as we list out these orbitals that these electrons are occupying, we have to start off with the orbital of least energy, and then list them till we reach the orbital of most energy. So it goes from least to most energy. So this arrow diagram is going to be very important for us to follow again. Coming back to our example, according to Aufbau, we always start off with the 1s. And in the 1s orbital, we have 2 electrons. So I write that as a superscript number 2. According to Aufbau, 2s comes next, and there's 2 electrons in there. After the 2s, we filled the 2p, which holds 6 electrons. After 2p, we moved on to the 3s, where we put 2 electrons. After the 3s, we moved on to the 3p, and we placed 6 electrons there. Again, this is where students are tempted to just continue to write from left to right. So you might be tempted to write 3d10 next. This would be wrong. When looking at the Aufbau diagram, after 3p comes 4s, and then 3d. So let's make sure we write that correctly. 3p6, then 4s2, and then 3d10. Here's my d orbital, 2, 4, 6, 8, 10. All right, after the 3d, we filled the 4p. You can consult your Aufbau diagram if you want to, just to double check that. That's 4p6. After the 4p6, you might be tempted to write this down. Again, that would be incorrect because after p comes s. So we would write down 5s2 and then move on to 4d. And we count those up, and there are 5 electrons in that last orbital. And this would be the electron configuration for technetium. I'm going to flip this over to the back, because the back was a little bit more challenging because we did not supply the orbital diagram for you. So you had to write this in. Again, we always start off with figuring out how many electrons are we going to put in this picture. Well, neon is atomic number 10. So I know I need to put 10 electrons in here. That's not a very big atom, so we shouldn't have to write too much for this. Just like before, we always have to start off at the 1s. So instead of it being supplied for you, now we have to draw it in. So I'm going to write 1s, and I'm going to put my 1 line there, because I know the s orbital only has 1 orientation in space, so I only draw 1 line. This orbital then can hold 2 electrons. So there's 1 up, 1 down. Next would come 2s, and since the 2s orbital is of higher energy, I'm going to write it above it. And I'll place in my 2 electrons there. So far I've drawn in 4 electrons. I still need to represent 6 more. After 2s, according to Aufbau, is 2p. Since they're on the same energy level, I'm going to just write them next to one another. Now I fill in 1, 2, 3. That puts me at 7 electrons. This would be 8, this would be 9, and that would be 10. And at this point, we have filled our neon orbital diagram. We can stop. We don't have to show all those empty orbitals because they don't exist. We only write what we need in order to place the electrons for that element. Let's translate this now into our electron configuration notation. So we did the 1s orbital first, and according to Aufbau that is the lowest energy, so I write that first. Then I write in my next one, which is 2s2, and after 2s2 came 2p, which I'll write with a 6. And then this would be the electron configuration notation for neon. hopefully this is helpful. I am going to complete these out and then put in a video, just a screenshot of the answer key to make sure that you have the correct answers for our coloring activity. It's very, very important that you have the correct answers, or else you'll end up coloring your periodic table incorrectly and then not have the right tool for writing electron configurations. So be sure to watch the next video where I've completed this entire document number 10. Thanks.